about the history of maintenance practices and the origin of total productive maintenance, which is shortly known as TP. Then the next one we have understands the basic features of total productive maintenance. Third one, understand the concept of equipment effectiveness and identify the losses that inhibit maximization of equipment effectiveness. The next fourth objective we have understands the method through which the losses can be eliminated. Then the next one we have established the important pillar for total productive maintenance. The next objective we have developed an understanding of autonomous maintenance and its role in the total productive maintenance implementations. And the last one we have to know about is the different known as group activities which is related to total productive maintenance and the structure of the TPM promotions in various organizations. So these are the key objective of today's sessions. Moving to next one. The next ones, these are the content of today's session. That means understand of total productive maintenance. Then we have to understand the characteristics of total productive maintenance. Then the next one we have equipment effectiveness and six big losses. Whenever you consider the total productive maintenance. Then next, the most important part of today's session, that is eight pillar of total productive maintenance. Then we have to understand the 12 steps of total productive maintenance developments. And the last one, that is known as autonomous maintenance, with related to total productive maintenance. So these are the content of today's sessions. Moving to next one. So let's understand what is the basics overview of total productive maintenance. So if you goes to point number one, it is the comprehensive approach to equipment's maintenance that aim to achieve perfect productions by minimizations or minimizing the breakdowns. The next one is slowdowns and minimization of defects. And the total productive maintenance involve everyone in the organization from the top management to frontline operators and integrate the maintenance into daily operation of facilities. So this point simply focus upon the aim and objective of total productive maintenance, where they can minimize the breakdown percentage and minimize the defect percentage by involve all three level of management. That means you have to involve top level of management, middle level of management, and the last one is the functional level of management, which includes the operator who are basically assigned to the equipments. So this is the first point. Moving to second point, the total productive maintenance is a proactive and preventive maintenance philosophy that focuses on maximization or maximizing the operational efficiency of equipments. So it is a philosophy which basically focus upon that is known as proactive and preventive maintenance, and the aim and objective of preventive maintenance is maximize the operational efficiency of equipment or machines. Then third one, we have the total productive maintenance emphasize empowering operators to take the responsibility for routine maintenance tasks and improve equipment reliabilities and performance. So third point directly indicate how the manpowers or that is operators are basically involved on routine maintenance, which basically includes day-to-day basis maintenance or maybe weekly basis maintenance or maybe monthly basis that is known as maintenance to improve the equipment efficiency, reliability as well as the performance, so that the organization will achieve the organization can achieve production oriented goals. So these are the overview of that is known as total productive maintenance. So the next important part, what are the total means the if you observe the second part of this particular slide, this T stand for total, and that means you have to focus upon a various amount of parameter. The first one is total efficiencies, then total life cycle of production system, and total manpower power coverage. That means the top level of management to middle level of management. Then last one is the functional level of management should be involved in case of total. Then P stand for that is known as productive. So you have to go for productivity maximizations. That means zero accidents, zero defects, and zero breakdown should be considered. And in case of M stand for the maintenance cover life cycle of the production systems, and it basically includes the individual process It also includes the entire plants, and it also includes the production management systems. So that is why if you combine the total productive maintenance, that means it basically focus upon minimization of breakdowns, involve all level of managements, maximize the operational efficiency of equipment, and the last one is it improve the equipment reliability and the performance. So this is the overall idea about the total productive maintenance. Moving to next one, so under the total productive maintenance, the whenever you word or whenever we pronounce the word total, that means it includes the total effectiveness, the total maintenance systems, and the total participation. So let's understand what are the different total effectiveness and total maintenance system, total participations. So if it goes to the first one, total effectiveness means this is ensured by the significantly established the preventive maintenance system, taking care of economy efficiency of the system. That means you have to reduce the wastage and minimize the cost reduction in every aspect. So that is why many company effectively implement the preventive maintenance in their systems, and this preventive maintenance is take care about the economic efficiency of the entire system whenever you provide any kind of maintenance to the system. The next one is that is known as total maintenance system. That means it establishes a maintenance plan for the entire life of the equipments. So whenever you focus upon equipment, the first important part is include that is known as equipment design stage. So the design should be very, that is known as maintenance free design should be there. During the operation stage, you have to provide the preventive maintenance, and in case of coupled with the maintenance improvement, that is facilitated easy of maintenance by repair or any kind of modification of the equipment. So if you combine this total maintenance system, the first important part is it define the entire life of the machines or equipment. The next important part is that is known as the during the equipment design stage, it provides maintenance-free design, first point. The second point is during the operation stage, the maintenance department is provide the preventive maintenance to improve the maintainability of the equipment so that you can arrange any kind of modification and repair should be done to that particular equipment. So this is all about the total maintenance systems. The next one we have that is known as total participation. So in case of total participation, as far as concerned with the maintenance departments, they have small groups are formed, and they are basically provide that is known as continuous maintenance activities throughout the system, throughout the plant, throughout the organizations. And in some cases, the small group and autonomous maintenance by the operator itself, they can also participate in case of total productive maintenance. So this is means total participation of, I repeat, the top level of management, the middle level of management, and in most of the cases, they also involve the operator to provide higher side of maintenance, especially reference to total productivity or total productive maintenance. So this is all about the introduction of total productive maintenance. The next one we have that is known as objective of total productive maintenance. The first point we have that is known as zero equipment failures. The next one is zero production defect, zero accidents, and the last one is maximize overall equipment effectiveness, which is shortly known as OEE. So how these benefits are basically implemented in case of total productivity or maintenance. So whenever you introduce this particular system, by the participation of all level of employees through the implementation of that is known as philosophical approach like preventive and proactive maintenance. And the next important part is you are introducing various amount of that is known as maintenance related strategies so that the productions will be go for higher side, less amount of defect should be observed, less amount of equipment failure should be observed, and higher side of that is known as safety should be considered as far as concerned with total productive maintenance. So these are the objectives, and by implementing these objectives in a particular organization, let's understand what are the benefits. So benefit, the first one is enhanced product qualities. So if you don't have any kind of defect, any kind of that is known as failure, automatically the raw material should be converted into finishing product, and that finishing product is directly goes to quality levels. The next one is reduce the downtimes. Through the introduction of total productivity maintenance, you can reduce the downtime by applied various amount of approaches like proactive maintenance approach or maybe preventive maintenance approach. The next third one, improve equipment reliabilities. So automatically, whenever you conscious about the autonomous of operators to provide the maintenance, the lifespan of equipments and machine will automatically increase. That indicate the reliabilities of the equipments. The next one is empower the workforce. Whenever you introduce the total productivity maintenance in your organizations, so the maintenance department is basically enhance the skill of different workforce from the that is known as middle level to that is known as the functional level of workforce. And the last one is the most important benefits of implementing total productivity maintenance is that it reduces large amount of what is known as economy in the form of cost savings. So these are the basic benefit on the total productivity maintenance. Moving to next one. The next one is let's understand the next topic that is known as history of total productivity maintenance. So if you goes to the first phases, the origins in between 1950 to 1960s, and the second one is developed in the year that is 1971. Then the principle and pillar were established during the 1980s, and this particular philosophy and concept will go for global expansions starting from 1990 to 2000s. And modern total productivity maintenance was introduced from 2000, year 2010 to presently, and it is specially designed for Industry 4.0. So let's understand. So if you goes to first one, the origin during the 1950 to 1960s. So the preventive maintenance was first developed in the that is known as US post World War II, and Japan adopted this particular concept, even adopted the preventive maintenance practices during its industrial recovery and modernizations in the year 1950s. The next is Nippon Denso. The Toyota Group companies was one of the first Japanese companies to aid this particular concept in their entire production system, so that they can achieve higher side of quality of products, less amount of the waste should be generated, less amount of defect should be considered. And the next one is they will effectively increase the lifespan of various machines and equipment who are directly involved in case of production systems. The next stage we have that is known as development of total productivity maintenance. 1971, the term the total productive maintenance was formally coined in the year 1971 by Seiichi Nakajima, a Japanese engineer at Japan Institute of Plant Maintenance, which is shortly known as JIPM. And the TPM involved from being a maintenance activities to company-wide productivity improvement strategies. So initially they have implemented this particular concept for maintenance activities, but during that mean period, 1971, it should be considered as a productivity improvement strategies. The next one that is known as TPM principle and pillars during 1980s. So by 1980s, the TPM was integrated into lean manufacturing and just-in-time systems as a part of Toyota production system. So in case of lean manufacturing, that minimization of wastes, and the next important part is respect for the employees, those who are involved in case of production activities. But if you goes to the next one, just-in-time concept, that is known as no inventories, zero delay, zero lead times, and the last one is higher side of quality should be considered. And it basically optimize the inventory level so that they are basically focused upon production activities. So by combining these systems in case of lean manufacturing, just-in-time system, these are the part of Toyota production system, which is known as TPS. The next one that is known as global expansions during 90s to 2000s, the TPM began spreading outside Japan, especially reference to US, European countries as well as developing economic countries. As that is known as Japanese philosophies to maximize that is known as maintenance activities to reduce defects. The next one is reduce the downtimes, reduce the cost savings, Last one that is known as modern, that is known as TPMs during year 2010 to present. It is basically applied to industry 4.0 technology like IoT, Internet of Things. The next is predictive maintenance, and as well as it is also implemented in case of artificial intelligence. So if you observe the history of maintenance, during 1950s, the breakdown maintenance was introduced. Again, if you go to the next one, 1950s, preventive maintenance was introduced. And under this preventive maintenance, they are basically focused upon the time-based maintenance and condition-based maintenance. The next one, 1975, the corrective maintenance was introduced. Here we can basically focus upon the mean time between failures and mean time to repairs. Then the year 1960s, they'll basically provide maintenance preventions. Then 1964, productivity maintenance, where they can basically focus upon that is known as breaking down maintenance, preventive maintenance, corrective maintenance, and various amount of that is known as maintenance practices, where they can basically focus upon preventive maintenance awards. Then again, 1971, the total productivity maintenance was introduced. Again, in the year 1981, that is the Japan Institute of that is known as Plant Maintenance, and TPM award was introduced in the year 1941. So this is the entire history of maintenance starting from 1952 till date, and it is applicable to the first generation of industry, the second generation of industries, the third generation of industry, as well as in case of the fourth generation, which is known as Industry 4.0, where you can use vast amount of IoT-based technologies, artificial intelligence, and many more technologies, especially reference to predictive maintenance, was introduced. So this is the entire history of total productivity maintenance, where we can find a large amount of changes which was basically initiated in case of Japan, and commonly it is spread to nowadays many developing countries. In case of India, we are also adopting these countries by the help of just-in-time or lean manufacturing, or we are also implementing these technologies in case of Toyota production systems. So this is the entire summary of history of total productivity maintenance. Moving to next one. The next one we have that is known as characteristics of total productivity maintenance. So according to Tompkins, in the year 1988, the TPM is advocate to the improve the whole production process. And the TPM encompass a broad range of activities which are designated to. The first point is improve equipment effectiveness in qualities, and the second one is that is performance readiness. That means the availability should be there. The second, that is known as broad range of activities, specially designed to, that is known as involve all departments, the function of companies from the top management to the shop floor peoples. So whenever you introduce, as I told, the total productivity maintenance, the first important part is improve the effectiveness of qualities and the performance, or which is known as performance readiness in the form of availability of equipment and machines. The second important point is that it involves all level of management, starting from the known as department, sub department, the function of companies, the top level of management to the shop floor peoples. So whenever you think about the total productivity maintenance, they are focused upon three important goals. The first goal that is known as zero breakdowns. The second goal is that is known as zero defects, and the third one is that is known as zero accident, so that the human life can be saved, and they can easily assign or allocate to different number of machines to improve the functional parameter of machine, which is basically dedicated for production related activities. So I repeat, the total productivity maintenance is not a management techniques. So it is a corporate philosophies or culture which has two core components. So let's understand the two basic and most important core component of total productivity maintenance. The first one is focus on improvement of equipment effectiveness, and the second important part is the participation of total employees in maintenance improvements. These are the core that is known as component of your total productivity maintenance. Moving to next one. The next one is the main features of this TPM by the Japan Institute of Plant Maintenance, that is shortly known as JIPMs, in the year 1971. are as follows. The first one is it is aimed at the maximizing equipment effectiveness. I will elaborate one by one. The next one is it establishes the Toyota system of productivity maintenance covering whole life of the equipments. The third one, it's cover all departments such as equipment planning departments, equipment use departments, and maintenance department, and so on. The fourth important point we have the total productivity maintenance is participated in by all staff members from the top management down to the shop floor workers. And the fifth most important features which include it promote the productivity maintenance through the autonomous activities. So under this characteristics, first the most important part is maximizing equipment effectiveness. So it indicates the availability of machines, and the next one is the reliability of machines. The second point is that it establishes the total system of productive maintenance, which cover the whole life of the equipments. So as far as concerned with the total productivity maintenance, as I told, it's not a management philosophy. It is a that is on this organization cultures, which basically provide large or dedicated site for maintenance management. And maintenance management is dedicated for improve the lifespan of the machines. The third important part is that it covers all the departments. So who are the departments? The first department is equipment planning departments. Most of the cases, the mechanical departments, the electrical departments, and they have assigned the planning manager or planning engineers. So these two departments are basically go for equipment plannings, or these are known as equipment planning department. The second one is equipment use department. So under the equipment use department, it is directly concerned or deals with the production department. Those are basically use these kind of machines and as well as the equipments. And the last one is it also include the maintenance departments. Those who are basically provide the number of classified that is known as type of maintenance to increase the lifespan of the machine or equipments. The next important part is the TPM is participated in by all staff members. So that means you have to involve top level of management, the middle level of management, as well as the bottom level of management. So in case of bottom level of management, we can also say that the shop floor workers are also involved. And in some cases, the operator are also involved to provide adequate that is known as maintenance to increase the effectiveness of the equipment or machines. The last important part is that whenever you involve all level of that is known as management, it promotes the productivity maintenance throughout the autonomous activities. So there is no need to explain all about the things. Whenever you involve all three level of management, it is the duties of these three different level of management. They can bring large amount of the promotional activities, especially reference to productivity maintenance throughout the organizations. So let's understand the other features of the total productivity maintenance. The first important part is, if you observe in this particular slide, that the TPM includes equipment management. The next one is they includes the plant maintenance. They are basically focus improvement in case of increase the efficiency of machines and equipments. Then overall equipment efficiency is automatically increased. And most of the companies, especially reference to industry 4.0 or industry that is known as 3.0, they basically provide basic education and training to improve the operators as well as the workforce level skills, so that they'll provide large amount of the known as predictive maintenance in across the organizations. The next is they are basically focused upon autonomous maintenance systems, continuous improvement. Under the continuous improvement, they are basically focused upon PDCA cycle. P stand for plan activities, do for do, C for check, and A for act cycle. So this continuous PDCA cycle is basically focused upon continual improvement in their maintenance management. The next, they will basically focus upon early equipment management, and the last important that is known as parameter of your total productivity or productive maintenance safety and quality should be achieved. So these are the characteristics of your total productivity maintenance. Moving to next one. So let's understand how this TPM basically work. So under this total productivity maintenance, The first important point is that is improve the effectiveness of the equipment or of the existing equipments. The second one is develop a autonomous maintenance program. So under the autonomous maintenance program, you have to involve all level of management. They will provide a planning activities. So depending upon the planning routine, they will go for the different education of providing the maintenance to machines and equipments. The third point we have developed schedule maintenance program, whether it should be in the form of day-to-day maintenance or whether it should be in the form of that is known as weekly basis maintenance, whether it should be in the form of that is known as monthly basis maintenance, or in the form of that is known as quarterly basis maintenance, or in some cases, in case of large industry, they will go for that is known as shutdown maintenance program. The next, they have conducting training and development information system so that they can involve all level of management to improve their skills to provide the large amount of information to understand about various machines, their hazardness, their difficulties, and how to overcome these difficulties in case of providing maintenance. The next one is develop early asset management program for the newer equipments. So in case of newer equipments, you have to record all the data, their specifications, their different parameters. Whenever you go for that is known as asset management, so record keeping should be must, and the details should be provided to all level of management so that they can easily understand what are the basic features of the machines or equipment and what are the working that is known as SOP standard operating procedures whenever they run the machines at a different functional levels. The next functions we have that is known as continuous practices or continuum practices, 8 pillar of total productivity maintenance. So that 8 pillar we'll understand in the upcoming slide how this 8 pillars is most important whenever a company is implement total productive maintenance in their organizations. So this is one aspect. The next one is uh, the organization structure for total productive maintenance. So let's take a small example of a plant. So if you go to their organization structures, plant-wise organization structure for TPMs, so they have TPM office is there. Plant managers are responsible for total productive maintenance. Under the plant manager, they have implement the five P's philosophies. They are basically implement to reduce the waste. And the next is they have autonomous maintenance systems, they have plant maintenance, they have individual improvements, they have quality maintenance, they have development maintenance, they have safety and health and environment related issues are there. And the last one is under the plant manager, they are basically provide education training to the shop floor workers. So these are the typical organization structure for total productive maintenance system. Moving to next one. The next one is how to implement the TPMs inside the organizations. As I told in the initial slide, especially reference to the introduction slide. So there are basically combines the different approaches of management philosophies like lean manufacturing, just-in-time concept, or 5S methodologies. So by combining this framework like lean manufacturing, just-in-time, 5S, the TPM can enhance the workplace surroundings. So how they have enhanced the implementation of TPM with respect to three objective of TPM, that means zero defect, the next one is zero breakdowns, and the last one is zero accidents. So the first important point is that they have to identify the pilot areas. The second one is restore equipment to the primary operating conditions. Then measure the overall equipment efficiency, which is shortly known as OE. Then address and reduce the major losses. And then next, if they find any kind of difficulties, then immediately apply the proactive maintenance. So these are the 5 steps to implement the total productive maintenance in the organizations. And if you go for broad understandings, the first important page that is known as awareness. So by providing education and training, you have to go for large amount of awareness programs to different level of management. The second one is that organization or organization structures. So you have to build up a particular team who are responsible for total productive maintenance. So after forming the team, you have to go for planning activities with respect to total productivity maintenance. The next is this team is basically go for implementation of various methodologies inside the organizations. So for example, one of the famous methodologies we have just-in-time concept, or you can go for 5S philosophies, or you can go for lean manufacturing. So by implementing these kind of methodologies, then after you go for assessment of that is known as various machinery equipments. That means you have to measure the overall equipment efficiencies through the assessments. So lastly is go for the continuous improvement. So under continuous improvement, as I told in the previous slide, you have to apply the PDCA cycle. So P stand for plan, D for do, C for checked, and X for X cycles. So this PDCA cycle is involved under the continuous improvements. So if it is not up to the levels or it is not satisfied the different level of management, again it should be goes to the phase 3, that means planning phase. So again they go for planning activities, then implementation, and finally go for assessment. So these are the 5 steps to implement the TPM or total productive maintenance inside the organizations. Moving to next one. The next one we have the equipment effectiveness and 6 big losses with reference to the total productive maintenance. So let's understand what are the equipment effectiveness and how the equipment effectiveness was calculated. So the first important part is that the TPM is simply clarified or stated the aim of TPM, that is maximize the equipment effectiveness, and further clarification is that it is also noted that it implies the effort directed at the improvement of the overall efficiency of the production equipments. So the first important part of TPM is that it basically maximize the equipment effectiveness and improve the overall effectiveness of the production equipments. So under equipment effectiveness is the product of three ratios. So they are basically focused upon operating rate, that is known as availabilities, and performance rate and quality rate. So I repeat, the equipment effective is basically focused upon product of three ratio. So under three ratio, we have to calculate operating ratio or operating rate, that is known as availabilities. The next is that is known as performance rate, and the last one is quality rates. So if you go for mathematical expression of your equipment effectiveness, that equals to operating rate into performance rate into quality rates. So what is the formula for operating rate? So operating rate means operating time divided by load times, and the operation times equals to lead time minus download or sorry downtime loadings time is available time on the equipment for the production per productivity work. Similarly, if you go for the performance rate, the formula equals to net operating rate into operating speed rate. So here the net operating rate equals to process amount into actual cycle time per operation time. And in case of operating speed rate equals to ideal cycle time divided by actual cycle time. Similarly, if you go for again the next formula, that is for performance rate equals to ideal cycle time into process amount divided by or process amount per operation time. And the last formula for quality rate, that equals to acceptable amount divided by process amount, and here acceptable amount equals to process amount minus effective amount. So these are the formula is basically used to calculate the equipment effectiveness. Under equipment effectiveness, you have to focus upon three ratios. So that is operating rate, performance rate, and quality rate. So I repeat, in case of operating rate, that equals to operating time divided by load time. Performance rate equals to net operating rate into operational speed rate, and quality rate equals to acceptable amount divided by process amount. So these are the formula basically used to calculate equipment effectiveness. The next one is that in order to maximize the equipment effectiveness, the total productive maintenance to eliminate the 6 big losses. So we have to understand what are the 6 big losses interferes the effective operations, and these 6 big losses are categorized in three classes. The first class is that is known as downtime losses. Under downtime losses, we have breakdowns and we have setup and adjustment is there. The second class we have that is known as speed losses. So under speed losses, we have to focus upon idling and minor stoppage. And the second one is that is known as reduced speed. The third one that is known as quality losses. So under third classes, we have two number of parameters are there. The first one is process defect and the last one is reduced yields. So let's understand what is the that is known as three classes and what are the different parameters included in these three classes. So under downtime losses, we have breakdowns. So these losses are caused by the unexpected breakdown. You cannot predict the breakdown of any kind of machine and equipment. So the second one is setup and adjustment. So under setup and adjustment, there are downtime losses due to setup and adjustment, such as changing the die in the press machines, injection machines, adjusting the equipments. These are the example of setup and adjustment. So if you don't assign any kind of that is known as skill operators, the adjustment time should be considered as that is known as breakdowns, one kind of breakdown, and due to this breakdown, it directly affect the entire effective of operations activities. The second class we have that is known as speed losses. So under speed losses, the first one is idling and minor stoppage. So under this point, we have idling occur when the equipment run without producing some regions, and minor stoppage occurs as a result of small problems which can be identified quickly and normal operation can be restored. The second one is that is known as reduced speed. So this is the loss due to difference between the design speed and actual speed of operations. So if a design speed of a particular equipment is more than 200, and if you go for the actual speed it is less than that is known as 100, that reduce the speed of your productions. So this is considered as a speed losses. The third class we have that is known as quality losses. So under quality losses, we have process defects. So these are the losses in quality of product caused by an equipment in terms of defect and reworking on these defects. Most of the cases, the steel plant are generate large amount of process defects. So this process defect generate large amount of scrap, and this scrap material are reworked or remade in the furnace to rectify these kind of defects. The next one, the last one under quality losses, we have reduced yields. So this kind of losses is the quality loss during the stage of startup and stabilization of equipments. So during the starting of or initiation of any kind of machines, if the machine will produce any kind of losses, these losses goes to that is known as reduced yield losses. So when the machine is stabilized, that should be rectified, and most of the cases, these are considered as the big six losses to the total productive maintenance. So to understand these three classes of losses, that means down losses, then speed losses or quality losses, you have to go for valuable operation times. So for first one, quality losses, the time loading time should be considered. The next one is in case of speed losses, the operation time should be considered, or in case of quality losses, the net operation time should be considered, which is most valuable operation time in case of these three classes of losses. Moving to next one, so how to overcome these six big losses in total productive maintenance. The first one is that is known as I told, the breakdown losses, setup adjustment, idlings on minor stoppage, reduced speed, reduced defects, reduced yield can be minimized after critical examinations or examine their inevitabilities. So these are the things should be observed in case of overcome of six big losses. Moving to next one. So let's understand how these six big losses will be uh, overcome in case of total productivity maintenance. So first we have to understand the sporadic when breakdowns, which means which leads to function losses for the equipments, happen suddenly or unexpectedly, causing the equipment to come to a grinding halt, and remedy for that one is restorations. So we'll understand what is that is known as sporadic breakdowns and chronic breakdowns. So sporadic breakdown, as I told, it is a unexpected that is known as causes due to unknown facts in case of equipment and machines. Similarly, if you go for that is known as remedy of sporadic loss breakdowns, you can directly go for restoration. So most of the cases, proactive maintenance strategies implement to restore the breakdown losses in the form of sporadic losses. The next is chronic breakdowns. It is a frequent and normally minor in their function is reduction times and hence generally not taken seriously. So chronic breakdowns occurs due to the combination of unclear causes. And uncover these hidden defects is eliminate chronic breakdowns in five major suggestions. So these are the minor that is known as breakdown, which is unknown to the that is known as operators. But if the chronic is be happen in case specific to a machines or equipment, in that cases you have to focus upon these five measures. The first one is maintain basic equipment condition, that means cleaning, lubrications or lubricating, and proper tightening of bolts. The second one is adhere to operating conditions to ensure optimum safety. When operator is involved, so they have to go for the proper operating conditions. The next one is restore deteriorations. That means parts indirectly involved in case of breakdowns. So if it goes to a gearbox, it consists of number of that is known as sub part and sub assemblies. So in that cases, you have to immediately go for restorations. Then the next one is correct design weaknesses. So in that cases, you have to change the equipment designs. So it is not possible in case of soft load, but you have to immediately inform to the that is known as maintenance manager, so that the correct design weakness should be easily eliminated by changing the equipment designs. So if it is possible, then improve operating and maintenance skills. That means you have to extensively go for training and education in case of operating conditions and maintenance works if avoid the human errors. So these are the five measures which is implemented in case of chronic breakdown. So let's understand what are the difference between the uh, sporadic breakdowns and the chronic breakdowns. So if we goes to the first one, which of sporadic breakdowns, the breakdowns occurs immediately. The maintenance personnel will provide the repairs. The technician, basically those who are involved, they go for technician breakdown analysis. So under technical breakdown analysis, they simply go for RCA. RCA stand for root cause analysis, and immediately they counter the measures and go for correct restores. So this is under sporadic breakdowns. And when they go for that is known as root cause analysis, they can find number of that is known as recurrence metrics. So these recurrence metrics is directly sent to repeat breakdowns. Again, the maintenance personnel provide the repair maintenance works, and again, the team break down the analysis. They can go for root cause analysis by supervisor levels as well as technical levels, and immediately they go for that is known as preventive or productive maintenance peer review countermeasures. So here they go for that is known as productive maintenance standard and identify the weak point of designs. So in this way, they can immediately that is avoid the breakdown losses, which basically includes sporadic breakdowns and chronic breakdowns. Moving to next one, the next one is setup and adjustment. So before starting this one, if you observe this particular figures, during the starting of machines, large amount of machine setup is required. So the maintenance personnel use various amount of spanners as well as tools to go for setup. And in some cases, after setup, they go for adjustments. So if you not properly adjustment, it directly degrade the quality of the known as your production output, or in the form of the known as error is basically included in case of product. So setup improvement can be accomplished by the distinguish between internal setup and external setup. So internal setup should be minimized by the converting to external setups. So pre-assembling or using intermediate jigs and are effective way to convert internal setup to external setups. So those who basically focus upon mass production system, batch production system, continuous production system, they are basically use jig and fixtures to avoid or to convert the internal setup into external setup. So improvement in case of adjustment can be accomplished by adopting industrial engineering approach. So under industrial engineering approach, in that cases, you have to go for that is known as various amount of proposed, the causes, the actual method applied, their effectiveness should be analyzed, and questions and better alternatives should be considered. So that is why those who are involved in case of setup and adjustment, they must go through the SOP of maintenance management. So every maintenance management department have their own SOPs. When the operator is go through the SOP, standard operating procedure, they can easily understand how to go for set up the machines, how to go for adjustment of the machine, so that they can increase the effectiveness whenever they introduce the total productive maintenance. Moving to next one. The next one we have idling and minor stoppage. So the TPM way reducing the idlings and minor stoppage can be summarized in following steps. The first step we have correct slight defect in parts and jigs. So if you find any kind of error in case of jig and parts, immediately go for corrections. Ensure the basic equipment condition are maintained. That means you have to provide proper cleanings, lubrications, tightening up each and every bolts which are directly fixed in the equipments. Review the basic operation in terms of operating standard, setup, adjustment procedures, and the performance. The fourth one, conduct the physical analysis. So physical analysis is avoid, that is 80% of breakdown in the industries. So if you find any kind of that is known as idling and minor stoppage, these are simply avoided through the physical analysis of machine and equipments. The next important part is adopt analytical approach to find out the root cause analysis of phenomenon which is directly dealing with idling and minor stoppage. And the last one is eliminate the design weakness. So if you find the design specification of machine is not proper, in that cases you have to directly eliminate these machines by replacing with the new ones. So these are the different measures with respect to idling and minor stoppage. The next one is reduce speeds. So at outset design speed should be compared with the standard speeds, since many a times the speed is vogally set which is never attainable, and minor defects so far unnoticed and unattended but coming in the way of increased speed should be immediately attended to. So the basic equipment conditions are required to be met. So whenever you go for reduce the speed, in that cases, the first important part is you have to focus upon the design speeds by the manufacturers. And whenever you increase the speed, automatically you have to identify or attend to avoid the big losses. So that is why during the initiation, that is known as commissioning of machines or equipments, the higher speeds should be tested by the skilled operators so that they can easily identify what should be the upcoming, that is known as error should be arise in case of that machine or equipments. The next one we have that is known as process defects. So as far as concerned with the sporadic breakdowns causes process defects, that means you have to immediately implement the restorations, and restoration is the method to correct these problems. In such cases, if you find the chronic breakdowns which causes quality defects, it should be taken through the investigation and innovative actions. So the quality control department, as well as by combining the maintenance department, you can easily tackle the chronic breakdowns which are directly affect the quality defects. And the last one is reduce the yield can be minimized after critical examine their inviolabilities. So if you find the machine is inevitable, in that cases you should remove the machine and minimize the reduced yields. So these are the 6 big losses to total productive maintenance. Moving to next one, the next topics which is very much important for today's sessions in case of total productive maintenance. That is 8 pillar of total productive maintenance. So what are the 8 pillars and what are the different objectives of 8 pillars? So first we have to understand this model was developed, and this model is basically developed by Nakajima from Japan, and these pillars are most vital pillars for implementing the total productive maintenance. So let's understand what are the objective and goals of these 8 pillars. The first objective is that is known as zero accident. The second one is zero breakdowns. The third one is zero changeovers or small stoppage, and the last one is zero defects. So to achieve this zero defects, zero accident, zero breakdown, zero changeovers, the company should implement this eight pillar in their organizations. So let's understand what are the eight pillars. The first one is autonomous maintenance pillars. The second one is focus improvement pillars. The third one is plan maintenance pillar. The fourth one is maintenance prevention pillar, which is shortly known as MP. The fifth one is quality maintenance pillar. The sixth one is office TQM pillars. The seventh one is that is education and training pillars. And the last one is safety and environment pillars. And if you observe this particular figure, the foundations of these TPM pillars are based upon 6S. So 6S philosophy is basically deal with the waste minimizations. And here, in case of that is known as maintenance management, it is basically avoid the various amount of breakdowns, accidents, defect, changeovers whenever a company is implement the total productive maintenance. So moving to next ones, the first pillar we have that is known as autonomous maintenance pillars. So let's understand from the autonomous maintenance pillars. So autonomous maintenance pillar is the process by which the equipment operator accept and share the responsibilities. So for example, a earth moving operator is involved. In that cases, he accept and share the responsibilities for the performance and the health of the equipment. The next important part is driving the concept of autonomous is the creation of expert equipment operators for the purpose of protecting their own equipment. So if you not share the entire that is known as equipment specification to other, in that cases, it should not be clearly communicated to others so that they are find large amount of difficulty when they provide any kind of maintenance. And most of the cases, the machine and equipment operators are known as the expert equipment operators for protecting their own equipment. The next important part is the autonomous maintenance is the cornerstone of that is total productive maintenance. So this paradigm shift that is known as the autonomous address is the transition in the operator perception from I run the equipments, maintenance fix it to I own the performance of the equipments. So these concepts should be or this paradigm should be accepted by the operator so that the simple operator should be converted to expert equipment operators. This is the first pillar of autonomous maintenance under total productive maintenance. Moving to next one, the second pillar we have that is known as focus improvement pillars. So under focus improvement pillars, it includes all the activities that maximize the overall effectiveness of equipments, process, plant through the elimination of losses and improvement of the performance. So this directly includes all activity. That means overall efficiency or effectiveness of equipment. They can easily focus upon maximize the efficiency of process, plant through the elimination of losses, and the last one is improvement of the performance. So how they have improvement the performance? If you observe the that is known as this flow diagram, first they have to identify the improvement area. The second they go for current, so they analyze the current process, develop the solution, implement the solution, monitor the result, standardize the improvement, review and refine. So in this way, a continuous that is known as focus should be established on that particular equipment, on that particular machine, so that the improvement or performance of that machine would be automatically maximized. The second objective of the focus improvement is to ensure the equipment to perform every day as well as it does not its best day. So the next important part, they'll focus upon the equipment performance on the day-to-day basis. The third one is the better our machines run, more productive is our shop floor, more successful our business. That is the next point. And the driving concept behind the focus improvement is reduce the losses. So it reduce the losses up to zero levels. And the last important point, maximizing equipment effectiveness require the complete elimination of failures, defect, other negative phenomena. In other words, it should be known as waste losses equal to equipment operations. So by establishing this flow diagram, that means identify the improve area, analyze the current process, develop the solutions, then implement the solution, monitor the results, standardize the improvement, review and refine. You can easily improve the that is known as overall effectiveness of equipments, improve the performance. Next pillar we have that is known as plan maintenance pillars. So under plant maintenance pillars, we have four number of phases. The first phases we have identify, plan, schedule, and the last one we have execute. So the objective of plant maintenance is to establish the maintenance optimal equipment process conditions as defined by Japan Institute of Preventive Maintenance, devising a plant maintenance system which basically provide the output in the form of no failures, no defects, and improve the quality of maintenance technician by increase the plant availabilities or machine availabilities. So by implementing the plant maintenance pillars, it is efficiently reduce the input to maintenance activities and build a fluid integrated system which basically include the first one is regular preventive maintenance to stop failures. That means you have to include periodic maintenance and predictive maintenance. The second one is corrective maintenance and daily maintenance practices to lower the risk of failures. Then breakdown maintenance to restore the machines to working order as soon as possible after the failures. And they are basically focused upon guidance and assistance in case of Jiku Hogens, which is a Japanese word, which basically means autonomous maintenance systems. So how the autonomous maintenance system is implemented? First, you have to identify, plan, schedule, and execute. So under identification phase, you have to go for identify the occurrence of the problems and observes what trigger the machine's failures. So for example, due to improper lubrications, the machines provide higher side of noise, and after running few days or few hours, the gears teeth are broken. So if you identify this kind of problem, immediately go for planning activities. So under plan the maintenance tasks, evaluate the scope of work to be completed. And the third phase we have that is known as schedules. So under schedules, the schedule the maintenance work to avoid any operational disruptions. And the last one is execute. So execute the plant maintenance on allocated schedules. So on the allocated schedules, you have to allocate your resources. That means you have to provide the spare parts, or if required, you go for adjustment, or if it required, you go for a replacement of this particular phase. So this is all about plant maintenance pillars. The next one we have maintenance prevention pillars. So maintenance prevention pillars refer to the design carried out during the planning and construction of new equipments that impart to equipment high degree of reliabilities. That means directly performance. The next is maintainabilities, economy, operabilities, safety, flexibilities, while considering the maintenance informations and new technologies to thereby reduce the maintenance expenses and deterioration losses. So second point of preventive maintenance is that the maintenance prevention is known as early equipment management, initial phase management, or initial flow controls. So the third point is that the classic objective of maintenance or maintenance prevention is to minimize the life cycle cost, which is shortly known as LCC, of equipment. So if you goes for the wide use of maintenance prevention pillar, they are basically focus upon prioritize your asset, stay on the schedules, track inventory levels, avoid over maintenance, keep detailed record for future scope of actions, conduct regular inspections to avoid various kind of breakdowns, train your team to upgrade their skills, and you have to introduce new technology in the form of maintenance, which is applicable to the modern era of industries like Industry 3.0 or Industry 4.0. Next pillar we have that is known as quality maintenance pillars. So as far as concerned with quality maintenance, so they are basically focused upon the most important part that is known as zero defects, customer satisfaction, customer demand, getting higher competitive edge, globalizations, and the next one is survival. So as far as concerned with quality maintenance, It is basically focus upon prevention action before it's happened. That means it must focus upon cause-oriented approach, and you have to go for reactive measures after it happens. Immediately go for proactive approach so that you can avoid the losses in the form of qualities. So quality maintenance like maintenance prevention built on fundamental learnings, structure developed within the focus improvement, autonomous maintenance, plan maintenance, maintenance are the major part of your maintenance prevention pillars under total predictive maintenance. So the next important part of quality maintenance, it basically provide the support in the form of the key objective of TPM to ensure the equipments and process are reliable, that are always function properly when they are basically needed. The next one, we have office of TPM pillars. So first we have to understand the office of TPM is applied the TPM activities to continuously improve the efficiency and effectiveness of the office functions. So let's understand what are the different office functions we have. So the office function are of two types. One is internal and other is external. So in case of internal, they'll have their internal customers. So for internal customers, they are implementing quick management system, which is shortly known as MIS. The second one, we have support to production functions, support the maintenance functions, supply chain management by implementing 5S implementations. For external customers, they have government agencies, they have different suppliers, they have stakeholders, and they have customers. So the objective of external customer is to cost reduction and work improvements. So in these cases, these support function may have significant impact on the performance of manufacturing or production operations, consist with the view of production system that includes not only manufacturing but also the manufacturing support activities, especially in reference to internal customers, and they are also go for supportive service in case of administrative and for other departments. So under the office of TPM pillars, these departments increase the productivity by documenting the administrative system, reducing the losses and waste, and they can raise the production system effectively by improving every type of organized activities that support the production activities. So, for example, equipment effectiveness improve the TPM focus upon identify and eliminating the effective losses in case of administrative activities. So, thank you.